A very warm good morning to one and all present over here class. Welcome to the digital platform of APS. Now this is Pawan Kumar. Today I will discuss some questions related to combinations. So class C. Now this question is proving question. Now question is let R is greater equal to 1 and lesser than n equal to n. Then prove that NCR means CNR is equal to C n comma R minus 1 is equal to, or this is the plus CNR plus, and this is equal to C n plus 1, this is R. Now this is the question we have to prove. So we are going to left hand side, take left hand side. So see the solution. LHS. In LHS, C times NR plus C times NR minus 1, and this one we can write NCR plus NCR minus 1, and the statements we can write factorial n upon n minus r factorial into r factorial plus factorial n upon n minus r plus 1 factorial into r minus 1 factorial. Now what we can write this? We can take common factorial n upon n minus r factorial. So what we will get in bracket 1 upon factorial r, and also we can take common 1 upon r minus 1 factorial, means r minus 1 factorial we can take common. So this one we can write 1 upon r, and this one 1 upon n minus r plus 1. This is the common part. Now when you will see, after taking common or LCM, this is n minus n factorial whole upon n minus r factorial into r minus 1 factorial. This one n minus r plus 1 plus r whole upon this r term will cancel. Now what will get the result? In numerator result is n plus 1. So factorial n times n plus 1 whole upon, this is the result, n minus r factorial with n minus r plus 1 into This result is factorial r. This result is factorial r. So what we can write? See, this result we can write this result we can write C n plus 1 r. Hence proof. Hence proof. Now this question is completed. Now I will come to the next question. The next question is question number 2. Now question number 2 is question number 2 is prove that n times n minus 1 c r minus 1 is equal to n minus r plus 1 into c times means n c r minus 1. This is the proof statement we have to prove. And in this question also given r is greater equal to 1, where r is greater equal to 1 and lesser equal to n. Now see. So we are going to take left hand side. Taking LHS, n times n minus 1 c r minus 1, result we can write n times n minus 1 factorial whole upon n minus 1 minus r plus 1 factorial into r minus 1 factorial. So n times n minus 1 factorial, n minus 1 factorial into n result will be n minus 1 factorial into n. This expression will be in numerator, and now denominator, what will be the result? This will cancel minus 1 plus 1, so n minus r factorial will be here into r minus 1 into r minus 1 factorial. Now n minus 1 factorial into n, what we will get the result? This is n factorial whole upon n minus r factorial and into this is written n minus r factorial. So what we can write? See, we can write this part n minus r means n minus r plus 1 from this expression we are going to rationalize. So factorial n whole upon n minus r factorial into n minus r plus 1 term we have rationalized with r minus 1 product. So this expression result will be n minus r plus 1 will be here. So this is the result n minus r plus 1 into this result is factorial n whole upon n minus r plus 1 factorial into r minus 1 factorial, and this is the result you know. This expression we can write n minus r plus 1 with c times or n time factorial n upon n minus r factorial means factorial n and c r minus 1. So n times c r minus 1 factorial. This is the result. Hence proved. Now this question is completed. Now you can see. Now in this question, what we have to do? In this question you will see n minus r, from n minus r plus 1 factorial we have rationalized. So n minus r plus 1 term factorial into n minus r plus 1 term will be n minus r plus 1 factorial. So this is n minus r plus 1 factorial, and into with into sign r minus 1 factorial, r minus 1 factorial. So this is the coefficient suppose, and we will put outside and don't touch this term and attach n minus r plus 1 factorial means n minus r factorial with n minus r plus 1 term. So result will be n minus r plus 1 factorial with into sign r minus 1 factorial, copy here. Now you will see this is the expression. This is the expression of n c r minus 1 means factorial n upon n minus r plus 1 into r minus 1 factorial. Now see. Now hence proof. This is the result, hence proof. Now I will come to the next question. The next question is, next proof is next proof is for integers we have to prove if n and r are two positive integers such that r is greater or equal to 1 and lesser than n. So see the next proof. Prove that C n r whole upon C n r minus 1 is equal to n minus r plus 1 whole upon r. So r is greater equal to 1 and lesser equal to n. This is the proof. Now in this question, what we have to do? Taking LHS, C n r whole upon C n r minus 1 is equal to factorial n upon n minus r factorial into r factorial whole upon factorial n upon n minus r plus 1 factorial into this is r minus 1 factorial. So what we can write this? Factorial n is cancelled and this expression will be n minus r plus 1 factorial into r minus 1 factorial whole upon this result is n minus r factorial into r factorial. And this format we can write n minus r term will cancel. So n minus r factorial into n minus r plus 1 we can write into r minus 1 factorial whole upon this result n minus r factorial into r minus 1 factorial into r. And now this format n minus r factorial will cancel, r minus 1 factorial will cancel. Result will be n minus r plus 1 whole upon r. Now this is the proof. Hence proof. Hence proved. Now come to the next question. The next question is question number prove that C NP or CNR plus C NR plus 1 is equal to C n plus 1 r plus 1. Now this is our proof. We have to prove these statements. Suppose we are going to take left hand side, and here this is the condition: r is greater equal to 1 and lesser equal to n, where r is greater equal to 1 and lesser equal to n. So given left hand side, suppose taking LHS, so C n r plus C n r plus 1. So this one we can write factorial n upon n minus r factorial into r factorial plus factorial n upon n minus r plus 1 factorial. N minus r minus 1 factorial will be here into r plus 1 factorial. Now what we can write this? We are going to take LCM, we are going to taking common part. So common part is factorial n upon, this is factorial r is common, and n minus r n minus 1 means n minus r minus 1 is common. So n minus r minus 1 factorial into factorial r is common. So in bracket what will be the result? In bracket here will be n minus r means 1 upon n minus r, and with plus 1 upon, here you will get r plus 1. Now this statement we can write factorial n upon n minus r minus 1 factorial into r factorial. This is the result, r plus 1 plus n minus r whole upon n minus r into r plus 1. So this r will cancel, result will be n plus 1. Now this result we can write n factorial into n plus 1 whole upon n minus r plus 1 factorial, n minus r minus 1 factorial into n minus r into factorial r into r minus 1. So this result what we can write? This result we can write n plus 1 factorial whole upon, this result will combine, this is n minus r factorial and this is r factorial. This is r plus 1 is here, so r plus 1 will be here. So r plus 1 factorial. And now this result we can write n plus 1 minus r plus 1 means this one we can write n plus 1 factorial whole upon n plus 1 minus r plus 1 factorial with r plus 1 factorial, and this is the result of n plus 1 c r plus 1. n plus 1 CR plus 1. Hence proof. Hence proof. Now this question is completed. Now you can see.